I'd like to take you on a little trip. This is cool roofs through time and space. What's a cool roof? A roof that is reflective to sunlight, stays cool in the sun. This helps keep our buildings cool, our cities cool, and our planet cool, and we get to save energy along the way. But there's a problem. New white roof might reflect 80% of sunlight. This word albedo, it means solar reflectance, or fraction of incident sunlight that gets reflected. But it gets dirty, as we all know, and this is a pretty bad example. This dirty roof now reflects only 50% of sunlight. And the temperature goes up. When the roof goes from clean to dirty, the temperature rose by about 15 degrees centigrade, 27 degrees Fahrenheit. Well, that's no good. We'd like to design and select cool roofs that stay cool, and by that I mean they stay reflective. Here's how we usually find out if a roof is going to stay clean and reflective over time. We put out coupons on a rack. In the US, we send these coupons to 3 different sites: Florida, which is hot and humid; Arizona, which is hot and dry; and Ohio, which is a milder climate, but it has poor air quality. We let the coupon sit out there for 3 years. And that's a little bit of a problem, because if you're working in your laboratory and you're trying to make the next great cool roof material, you don't want to wait 3 years to find out, have you got the right one? And this shows you what happens over the course of 3 years. I have 2 different types of white roofing. One is what's called a field applied coating, gets sprayed onto an existing roof. And the other is a white metal roof, and that got coated in the factory with something that tends to stay pretty clean. And I've got pictures here taken every 3 months for 3 years at each of the 3 sites. And we can see that the reflectance of the field applied coating, that's the upper one, is dropping more than the reflectance of the white painted metal. So you'd like materials that behave more like that white painted metal, but you don't want to wait 3 years to find out if you've won. So I bring you the cool roof time machine. We start with a device that's called a weatherometer. It's just a weathering apparatus. It exposes materials to cycles of heat and humidity and ultraviolet light. To that, we add something that we've developed at Berkeley Lab, which is our soiling apparatus. It uses a carefully calibrated combination of soiling agents: soot and black carbon. Soot is black carbon, and dust, humic acid, which is a proxy for dead organic matter like leaves, and salt, because that affects the way the things stick to roofs. What we do is we put a roofing coupon in the weatherometer for 1 day. It gets exposed to UV, to heat, to moisture. Then it goes into our soiling apparatus. It gets sprayed with a soiling mixture for about 10 seconds. And then it gets dried under a heat lamp. 5 minutes, 10 minutes total. Then it goes back into the soiling apparatus for another day to simulate the effect of wind and rain on the reflectance, that is to say, natural cleaning. And then we're done. 3 years down to less than 3 days. And this is what it looks like. First, the material is clean. Then it's conditioned. It's spent a day in that weatherometer. Very little happens. Then we spray. After 10 seconds of spraying, we let it dry. Goes back into that weatherometer for a day. Gets cleaned off a little bit. And you can see that the reflectance has dropped, but it's dropped in different ways depending on what the material is. I'll let you guys see it once more. Boom. So 48 hours, 10 minutes. Well less than 3 days. Question is, does it work? The answer is yes. What I'm showing here is how well the reflectance after 3 days in our laboratory apparatus matches the reflectance measured after 3 years of natural exposure. It's a very nice match. And we use this as part of the process for making better cool roofs and for getting better cool roofs to market faster. So you don't have to wait 3 years to find out how well it performs. So that's our little trip through time. Now a trip through space. We'd like to know how cool are the roofs in this state already. If the roofs are already cool, there's not much potential to make things better. But if they're not cool, if they're dark and absorbing all the sunlight, well, there's a great deal of room for improvement. We took advantage of the fact that the USDA, of all organizations, has got a program called the National Agriculture Imagery Program, in which airplanes fly over the whole country pretty much, and they take 4-band images. And I'll show you what those mean in a second. And the images can be used to detect crops, or in our case, to figure out how reflective are the roofs. So this instrument up here is collecting images not just in blue, green, and red, that's what you use to make a color picture, but in one more band called the near infrared, which is not visible to our eye. So here are 4 images taken in the blue, green, red, and near infrared, and those are those very narrow bands in which they're taken. This is the solar spectrum superimposed over those 4 bands. Now, by having that extra narrow spectrum in the near infrared, we can tell more about reflectance to sunlight, which is about half invisible. But we need to also know how do roofing materials reflect in each of those 4 bands. So in our laboratory, we measured that reflectance versus wavelength, including the reflectance in each of those 4 bands, for nearly 200 different roofing materials. And we developed a correlation, and it's a very nice fit. So from those 4 narrow band reflectances, we can determine the reflectance of the roofing product. And we also went out to roofs to measure the roof reflectance on site with a device called a pyranometer. And here's my PhD student doing exactly that. So these are what you'd say are ground truthed, or in our case, roof truthed. And what we found is that statewide, on average in these cities, the roofs are maybe 20% reflective. So there's a lot of potential for improvement. A white roof, even a dirty one, is about 50–60% reflective. And now I want to introduce to you our new online tool that you can go play with at home at AlbedoMap.LBL.gov. And we're going to go to the Oscars, specifically the Kodak Theater in Hollywood. I think it's now the Dolby Theater. So on this website, you can go to one of 5 cities for which we have complete maps. Here we're starting in Hollywood because, hey, why not? It can't hear you. It's just a movie. Now I'm going to turn on the layer that shows the reflectances of the roofs. And we're going to click on the building where you would see the Oscars, the Dolby or Kodak Theater. And we can see, or you could see if it was bigger type, that it's just about the same as the average reflectance for roofs in that city of Los Angeles. But you can also see that there are white roofs here shown in blue, which are about 60% reflective. You can go find your own buildings. And thank you very much.